Hello and welcome. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. Today we're going to be talking about one of the most common machine learning models, and that is linear regression. Now, linear regression is a little different than the classification models that we've been using. Instead of predicting whether a point belongs into a certain class or not, a linear regression model, or just regression in general, predicts continuous points on a line. So let's go ahead and look into how we can use this and how we can actually train a model to do this for us. Okay, let's start talking about linear regression by working through an example problem. So as you can see, I have some example data up on the screen. It's just a simple mapping of x values to y values. Now in this case, the x is an input feature and the y is the output that we're looking for. And the data tends to be trending to the upper right hand corner, so it's a positive correlation. And the whole point of linear regression is to come up with some function that will map the data so that we can input an x value and come up with some predicted y value. Now, if I draw a line right here, this is a fairly good representation of how the data looks. And this is what linear regression is trying to do. It's trying to come up with this line where it's sort of halfway between all the data, and we're just trying to minimize the error from our known data points and come up with just the general trend. And if you remember, the equation of a line is y equals mx plus b, where m is the slope and b is some offset on the y-axis. And once we have this line, or a initial line anyways, we need to figure out how far off that line is. And so what we're trying to do is just compare our known data points to that predicted line, and we're going to try to minimize these distance that I have represent in this yellow dotted line. And to do that, we're going to use something called mean squared error, where we're taking those distances and we are going to subtract the known points from the predicted line to get those distances, and then we're going to square the distance and take the average. And this comes up with the MSE value. And the whole point of linear regression is to just minimize the amount of error that our predicted line has, which will give us the best trend, hopefully. Now, how does this relate to machine learning? Well, if we take that original line, we can actually change this to be the y hat, which is, again, the predicted y value, is going to be equal to the weights of the network that we're building. And those are going to be multiplied by our input values. And then we're going to add some bias. So you can see I sort of color coded them the same, but it's exactly the same as the equation of the line. We're just adjusting weights and we're adding a bias in order to come up with this line. And now this is a very simple problem. I am representing only one feature here, but we can actually do this for multiple features just by expanding this equation out. So take weight 1 times the first feature plus weight 2 times the second feature, and so on for however many features that we have. And then add the bias at the end, obviously. So that is all linear regression is doing. We're trying to come up with some mapping of weights to the features and a bias value in order to come up with our equation of the line. It's as simple as that. And I will go ahead in future videos. I will be implementing this on various data sets. Again, it's one of the more well-known machine learning models, so we'll definitely be using it. But I'm also going to be creating a linear regression model from scratch so you can see exactly how they work, exactly how you can apply the math to create your own model. So stay tuned for those. If you got anything out of this video, please like and subscribe to the channel. But for now, I am out, and I will see you guys later. Thanks.